In this Excel demonstration, we're going to talk about the standard normal curve. So I'm using the Excel workbook called Excel Demonstrations Standard Normal Curve. So this workbook has 3 worksheets down here at the bottom. So areas under the standard normal curve, finding a z-value given an area, and then some application problems. So this demonstration is going to be specifically finding the areas under the standard normal curve. So we're going to work with this first worksheet. So in this very first one, we want to find the area under the standard normal curve, and we want to talk about the 3 different cases. And so case 1 is finding the area to the left of z. So notice the picture that we have over here on the right. So we have a picture with the area to the left of z shaded, and it's shaded in gold, and so that's the area that I'm trying to calculate. So let's talk about what Excel function I'm going to use. So my example says find the area to the left of z equals 1.21. So I'm coming up here to insert function, and I'm going to type in normal distribution, and I'll say OK or go. And this very first one, the third one down says normal.s.distribution. Because this is a standard normal curve, that's the function I want to pick as far as this problem is concerned. So it returns the standard normal distribution where it has a mean of 0 and a standard deviation of 1, given that we're going to put in a z-value. So let's click OK. And then it says, well, what z-value are we doing? Well, let me move mine out of the way to see what it is. 1.21. And cumulative, so that's just that question of whether you want to return the cumulative area or not. So we want to say true because we want the cumulative area from the left all the way up to that z-score. And then I'll click OK. So 0.886861. So the rounding rules when we're working with the area and the standard normal curve is we're going to go to 4 decimal places. This makes us consistent with the tables in the book. So we'll say 1, 2, 3, 4. So our final answer for the area to the left is going to be 0.8869. Case 2. Case 2 is finding the area to the right of z. So notice the difference, and notice the shading, and so it's shaded over here. This is the complement, right? And so the area that the standard normal curve gives us is this blue unshaded area to the left, but we want to find this gold area, which is the complement. So we're going to use the idea of complement and the 1 minus. So in this one's case, we're going to say, so let's come over here. I'm going to say 1 minus normal dot standard distribution negative 1.42 comma true, because we want it to be cumulative, 0.9222. So there's my 4 decimal points. I didn't have to do anything different for the rounding rule. So 0.9222. The last case, so moving down to case number 3, the last case is finding the area between the 2 z values. And so when I'm finding the area, I'm going to go all the way up, and I'm going to pick the biggest z value, regardless of where it's at. I'm going to do the area all the way out to this right z value. Then I'm going to subtract the area up to the other z value, the one that's on this the lower z value, And when I subtract that area away, I'll be left with this area in the middle. So let's do that calculation. So I'm going to say equals, and then I'll say norm dot s dot dist, and we're going to go the furthest value out, 1.81 comma true. Then we're going to subtract norm dot s dot dist, and the value on the left, negative 1.02 true. Point 8110. So 4 decimal places, 0.8110 is the area under the curve, this gold shaded area, from negative 1.02 to positive 1.81. So the next video that you'd want to watch is finding a z-value given an area. So we'll be moving over talking about this second worksheet.